Hey, AP Chemsters, this is Mrs. Vanderlei bringing you Blankwalle 5.7. This is gases and chemical reactions. We're looking at stoichiometry one more time. So when you think of stoichiometry, I hope you start thinking of BCA tables. And so you're going to need your moles and your mole ratios. That's what your C does. Divide by what you have, multiply by what you want. And then if needed, you need to use the ideal gas law to solve for moles of gases and do what you need to do. So then once you find out what your moles are, stick it in your equation and you can solve for moles of whatever else you're looking for and proceed on. So for example, methanol can be synthesized by the reaction below. You're going to have some carbon monoxide and some hydrogen gas, and you're going to make some methanol. So this is what volume in liters of hydrogen gas at a temperature of 355 Kelvin and a pressure of 738 millimeters of mercury do we need to make 35.7 grams periodic table of methanol. So what do you think the first thing we need to do? I'm hoping you say we have to balance it, of course, Mrs. Vanderlei. So go ahead and balance that. Well, hopefully it didn't take you too long to figure out you need a 2 here, okay? And so what is being asked for? What volume in liters of hydrogen? So you're given temperature, you're given pressure, you're needing volume. So what's missing out of Pivner? Well, let's take a look here. What's missing out of Pivner? We're going to need this to figure out V. We have P, sort of, we have to convert anyway. We don't have moles, we'll always have R, and yes, we do have T. So if we're looking for V, and we want moles, we need to figure out moles. Well, is there anything in this problem that will get me there? Well, I do have 35.7 grams of methanol, don't I? So I will go ahead and figure out the molar mass. Why don't you do that too while you're at it? I got 32.05 grams of methanol in 1 mole of methanol. And so how many moles of methanol do we have? Hopefully you got 1.11 moles. So now what? I'm going to plug that in here. I made 1.11 moles of methanol. That means I had this in my C, because what's always up here? I didn't put it in there, but it's a 0, isn't it? So the C is what I really need. So what's 1.11 divided by 1 times 2? Well, hopefully you got 2.22. So go back to my Pivner. Do I have pressure? Yes, sort of. I need to convert it into atmospheres. Do I have volume? No, that's what I'm looking for, though. Do I have moles of hydrogen? Yes, I do. I have 2.22. Do I have R? Of course I have R. Do I have T? Yes, they gave it to me. So this is what I have. And so now what? I need to figure out, well, what's my volume? Go ahead and solve for V while you're at it. Did you get 66.7 liters? That's what I got. Hopefully you did too. So that's how you go about doing a problem using stoichiometry and gases. So let's look at problem number 28. All right, so in problem number 28, it says in the reaction below, 4.58 liters of oxygen is formed where you're given pressure, you have liters, you have temperature. How many grams of silver oxide are decomposed? So once again, what's given? I have liters, I have pressure, I have temperature of oxygen gas. Well, what's missing? I'm missing is the moles, all right? So can I solve for moles? Well, of course I can. So, whoopsie, sorry about that. Go away, there we go. So here I have this again. So I have pressure, I have volume, I always have R, I have T, I can solve for moles. What am I going to do with that? I bet I'm going to put in the BCA table, because what is it that I want? I want grams of the solid, so I need moles of that solid. I can find out moles from a BCA table. So what's the first thing you ought to do? Well, hopefully you said you need to balance it. So go ahead and balance this. Oops, here we go again. Did we get a 2? And did we get a 4? I hope so. So now I need moles of oxygen. Why don't you go ahead and solve for moles? So pause this, do the work, and see if you get what I get. Okay, well, welcome back. And let's see here. I got this in here to start with. So yes, I have 0.980 atmospheres times liters. Here's moles, and there we go. And when I solve for moles, I got this answer here. So what do I do with that number? I need to put it in the BCA table. So I produced that many moles of gas. Well, guess what? That's how much my C is. So this, I needed this number right here, so I can go 0.178 divided by 1 times 2, and that's where I got 0.356. So that's obviously how much I've had, assuming this reaction goes to completion. So now I have that many moles of silver oxide. So can I figure out how many grams? Yes, I can. Why don't you go ahead and do that? Pause it, figure it out, and come back when you're done. All right, so hopefully you found the molar mass of the silver oxide. So I put 1 mole here. I put the molar mass of silver oxide there, and I end up with 82.5 grams. So it's going to take a lot of silver oxide to make 4.58 liters of oxygen, okay? So why don't you go ahead and try number 29 all by yourself. So pause this, work through it, see what you're given. Oh, you're given STP. That made your life a tad easier. And come back when you're done. All right, how'd you do? Well, this is what I did. Oh, let me extend a little more. There you go. So I have my balance equation. And once again, if I would need grams of water, which is not a gas, so I had to use the BCA table to figure out how many moles of water I had. But I do know I have 1.24 liters of hydrogen gas at STP. So I figured out how many moles. I didn't have to use Pivner. I just used the molar volume. I put 22.4 liters on the bottom, 1 mole on top, and I get this many moles of hydrogen gas. So 0.0554, that's how much I started with. So this divided by 2 times 2 is 0.0554 moles of water formed. Here's my molar mass. So I got 0.998 grams of water. Let's see what problem 30 is all about. Well, silly Mrs. Vanderlooy, problem 30 is in the next section. So this is a great time to stop section 5.7. So I'll end with, don't wait to be great. See you next time. Bye-bye.